Good morning to all. Welcome back to my channel. Name is Salim Mubarak Yuge, Junior Consultant, National Skill Training Institute, Calicut. Today we are going to the some technical part, electrical technical part. So I am going to discuss 50 important questions regarding the chapter three-phase induction motor. Before going to this video, one suggestion for you that you have to read and understand the chapter three-phase induction motor. Otherwise, it is not useful. So you have to understand the three-phase induction motor working, condition, type of starter, and then power flow diagram. Okay, likewise. Only then it is useful for you. Okay, so first we can go the first question. So what is the first question? For high starting torque, the most suitable three-phase induction motor is. So we are going to attend the objective questions. So as in my experience, one suggestion for you that you have to read the question and option first. So read very carefully. So otherwise you will get a wrong answer. So you are read the question and answer carefully, so you will get the idea from that one. Okay, so for high starting door, the most suitable three-phase induction motor is option A slip ring induction motor, the squirrel cage induction motor, option B, then option C is double cage induction motor, option D is deep bar induction motor. So there's some explanation is there. So in mainly induction motor, there is a two classification is there. One is squirrel cage induction motor, other one is slip ring induction motor. In squirrel cage induction motor, there is a two classification is there, deep bar or double cage induction motor. So one equation you can see here, torque T is equal to torque is equal to K into S into R2 divided by R2 square plus Sx to the whole square. So you can see S is the slip, R is the rotor resistance, and X2 is the rotor reactance. So in the figure you can see that when the rotor resistance is increased, you can increase the torque. So you already studied that in slip ring induction motor, there is a facility to connect external resistance into the rotor. That is important in the slip ring induction motor. In slip ring induction motor, there is a facility to connect the external resistance to the rotor. So when you are connecting the external resistance, the rotor resistance will be increased, the torque will be increased. So our answer is slip ring induction motor. Okay, so our answer is slip ring induction motor. That is option A. So before that, one more thing is that for high starting torque, so means the starting time you need the maximum torque. That is a word, maximum. The starting time you need maximum torque. So where is our application? The best example is lift. So when you're starting the lift, what will happen? There is a full load, or 8% or 9% will be in the lift. So the starting time you need the full torque or maximum torque you need. So for operating lift like application, we are using slip ring induction motor. Okay. So and other one, double cage and deep bar is a classification of squirrel cage induction motor, and then these both are already same. And this double cage and deep bar induction motor starting torque will be more than the squirrel cage induction motor. There's some another arrangement is there. Okay, so I'm not going to that one. I'm going to the next question. Next question, what is crawling in induction motor is caused by? So read the option. What is a high load, low voltage supply, harmonic developed in the motor, improper design of motor. So crawling, what is the question? Crawling in induction motor is caused by. So what is a crawling? So that you have to understand what is the crawling. That is an important thing. So what is the crawling? The squirrel cage induction motor has a tendency to run at a very low speed compared to its synchronous speed. That is known as the that is phenomena. It is known as crawling. Okay, so what is the crawling? Squirrel cage induction motor has a tendency to run at a very low speed compared to its synchronous speed. This is known as the crawling. The resultant speed is nearly 1/7 of its synchronous speed. Okay, so when you are crawling time, the speed of the rotor will be 1/7 of the synchronous speed. So what is the synchronous speed? There is another term. I think you know it in when you are studying the induction motor, there is an important term is the synchronous speed. So in synchronous speed, you can find using this equation 120 F by P. So synchronous speed means this is the speed of the rotating magnetic field. So when you are applying a voltage into the stator will be produce one rotating magnetic field. The speed of that rotating magnetic field it is known as synchronous speed. Due to that rotating magnetic field, the rotor will be start to rotate. Okay. Due to that rotating magnetic field means that rotating magnetic field means that speed will be synchronous speed. So rotating magnetic field, the rotor will be start to move. Okay. So sometimes also some harmonic flux will be there. So there is actual flux will be in the stator. Stator will be produce one actual flux that is in the air gap. It will be rotating in the single speed. In okay, and also in with the actual magnetic field, some harmonic flux will be there. So the harmonic flux speed will be different. So it is normally it is 1/7 or 1/5 like speed of the synchronous speed. So actual speed you can understand is a 1500 rpm. So some another harmonic flux will be there. That speed that harmonic flux speed will be 1/7 of the synchronous speed. So sometime the rotor normally the rotor flow the synchronous rotating magnetic field that is a synchronous speed. Sometimes it will be follow the harmonic flux or harmonic flux speed that will be in the that phenomena it is known as a crawling. Okay, so it is a reason is the harmonics developed in the motor. So harmonics developed in the motor is the reason for the crawling. So actual magnetic field will be there, some harmonic flux will be there. Normally rotor will be flow the actual magnetic field, but sometime it will be follow the harmonic flux. That time the motor car rotor will be rotating the low speed. It is or nearly 1/7 of the synchronous speed. The condition is known as a crawling. Okay. The next question, the function of the starter in the induction motor is to. So what is the function of the starter? This is our question. To control the supply voltage, to start and stop the motor, to limit the starting current, to control the speed of motor. So first you have to understand what is the use of the starter. Before that you have to understand what type of the starter. So just I am giving the explanation 0 to there is a mainly 4 type starter is there. So 0 to 5 HP motor. So आपका साथ एक induction motor is there. So it is the range is 0 to 5 HP. Then you are using the dual starter. Dual starter means direct online starter. In this direct online starter, there is a no arrangement to reduce the starting current. Okay, so it means that 0 to 5 HP motor, the starting current is normally is not a high. It is normally it is not a high, but 5 to 15 HP motor, we are using the star delta starter. 5 to 15 HP motor, we are using the star delta starter. Above 5 HP, we are using auto transformer starter. Okay, then the slip ring, if there is a slip ring induction motor, we are using rotor resistance starter. Okay, so in the start, you can see that star delta starter means you know that in star and delta connection. So star connection, there is a star connection and delta connection. There is a sorry, the star and delta starter will be the auto transfer. In both these two conditions, the voltage per phase will be reduced. So means the current will be also reduced. So basic application of the starter is reduced to the starting current. So our question is the function is to limit the starting current. Okay. So starter is used to limit the starting current. In the starter, there is a start and stop will be function. There is a start and stop facility will be there. Okay. So, but the main application is the limit the starting current. And the next question is the start delta starter of an induction motor. So, what will be doing the start delta starter? So, means what is the working inside the start delta starter? So, one option is insert the resistance in the stator circuit, insert resistance in the rotor circuit, changes the direction of the rotor of the motor, applied reduced voltage to the start at the starting time. Okay, that will be the, so you can see that in delta connection. So when you're taking the delta connection, so what is the phase voltage and line voltage? You know the same. In delta connection, phase and line voltage is the same. In star connection, phase voltage will be equal to VL by root 3. So it is reduced by 1 by root 3 times. So voltage across the winding will be reduced. That is an important point. So when your motor winding is connected to the star, okay, compared to the delta connection, per phase voltage across the one phase will be reduced by 1 by root 3 times. So if the voltage is reduced by 1 by root 3 times, the current will be reduced into the 1 by 3 times. So just an example. So you are an induction motor rating of 5 ampere. Normally the starting time it will take 5 to 6 ampere, so it will be 30 ampere. So in the starting time it will be take 30 ampere. When you are using the star delta starter, it will be reduced 30 divided by 1 by 3. 30 into 1 by 3 means it will reduce to the 1 by 3 times, means 30 ampere starting current motor will be take only 10 ampere when you are using the star delta starter. Okay, so our answer is that it is applied reduced voltage. So it is applying the reduced voltage to the starter. So means starter will be produced reduce the applied voltage. That is our answer is option D. Okay. So other one is the fifth question is, in case of single phasing occurring on the running condition of an induction motor, okay, running position of an induction motor, the motor will. So what is the single phasing? What is a single phasing? Okay, single phasing. What is a single? That is our next one. So in three-phase motor must be connected to a rated voltage and load for a proper working. If due to some reason one phase of the motor gets disconnected, the motor will be continued to run from active two-phase supply. It is called a single phase. So first you have to understand what is a single phase. And there is a three phase will be there RYB. Due to some reason one phase is disconnected, so the supply will be from only two phases. The loss of current from one phase is the current flowing through the remaining two phase will be increases. So due to that reason the current from the two phase will be increased. Okay, so what will happen? Draw unbalanced and excessive current. That will be our answer. So when your single phase occur, there is unbalanced and excessive current will be there. So one another additional point is there. So when you are connecting one overload relay in each phase, what will happen? It will be set in a particular current, 2 ampere, 3 ampere. You can set any, depends on the motor. If any fault to single phase occur, the if the three phase of the motor are fitted with an overload relay, if there is any increasing in the value of the current, then this relay activates automatically and the motor. So means when you are connecting one overload relay, so one accidentally one single phasing is occurred. So what happened in the circuit? Single phases happened. That time it will be unbalanced or excessive current will be passes through the overload relay and it will be trip the circuit and the motor will be protected. The next question is the, in three-phase induction motor running at a slip S, the mechanical power developed in terms of air gap power PG means air gap power. So there is a for option S minus 1 into PG divided by 1 minus S into S into PG. So that is an important, another important one is in the induction motor is the power flow diagram, is the power flow diagram. So when you understand the power flow diagram, you can do many problems regarding the induction motor. So in the objective question, the problem mainly asking regarding this power flow diagram. So you can see where any motor input will be there, or stator input. Stator input means motor input. that will be 3 root 3 VL into IL into cos phi, like will be there. So due to the stator winding, there is a stator iron and copper loss will be there here. Okay, stator iron loss will be there. Then stator output or rotor input. So means the stator and the rotor is connected through air gap. In between stator and rotor, there will be air gap will be there. When you're giving the supply in the stator, after stator copper loss and stator iron loss, it will be it will go into the air gap and to the rotor input. So air gap power, you can see that is air gap. PG means air gap power or stator output or rotor input. Three are same. So after that, when you're reaching the rotor, there is a rotor copper loss will be there. Okay, remaining the rotor copper loss, it will be reached to the gross mechanical power developed. Okay, so one equation is the S into P2. So it is a mathematically proved one equation is the S into P2 or S into PG. P2 and PG both are same. Rotor input or air gap are both are same. S into P2 means S is a slip. So when you are multiplied slip into the rotor input, you will get the rotor copper loss. You know the slip value is a maximum value, it is a 1. It is 0 to 1. So it is S into P2, you will get the rotor copper loss. Remaining part means S value is maximum 1. So 1 minus S into P2 will be equal to output power or gross mechanical power. Okay. Then after friction and wind loss, it will become to the rotor or motor output. Friction in this actual output. So what is our question? Mechanical power developed. So you have to find the mechanical power developed. It is 1 minus S into P2 or 1 minus S into PG. So it is 1 minus S into PG. That is our correct answer. Okay. So next question. Power factor for high speed motor compared to the low speed motor. So is practically proved that when the speed of the motor, induction motor is increased, the power factor will also increase. When the speed of the motor is increased, the power factor will be also increased. So at the high speed time, the power factor will be high. So power factor at the high speed time, it will be high compared to the low speed time. The answer is option A. Next question, rotor of induction motor runs always. So rotor of induction motor, so you know there is a important terms. One is synchronous, we already discussed that one. So the rotor of the induction motor is follow the rotating magnetic field. So what is the speed of the rotating magnetic field? It is the synchronous speed. So synchronous speed is the revolution of the magnetic field in the stator winding. The relative though, what is the reason for rotation of the rotor? Is the relative speed between magnetic field or rotating magnetic field or rotating magnetic field and the rotor winding is the reason for the rotor rotation. So if there is no relative speed, there is a no rotation will be there. So when you are applying one supply into the stator, it will produce a rotating magnetic field. Due to the rotating magnetic field, the rotor will be start to move and follow the rotating magnetic field, but it's not reach the speed of the rotating magnetic field. Okay, if it is reached, what will happen? If both speed are same, what will no relative speed? So both single speed and rotor speed are same. There is a no relative speed will be there. The motor will be stopped. So actual condition, practical condition, the rotor of the induction motor run always less than the synchronous speed. Okay. The next one is three-phase induction motor operates on power factor. So what power factor the three-phase induction motor usually operates? 0.6, 0.8 lead, 0.8 lag. So you know that induction motor, the motor containing winding. So winding means an inductive property. So it is a lag condition. So lagging will be there. You can say 0.6 or 0.8. Practically it proves that most of the induction motor is working in a 0.8 lag condition. 0.8 lag condition. So next, we already discussed this question. The phenomenon of squirrel cage induction motor sometimes showing the tendency to run about the 1/7 of rated speed. It is known as, so first we are already discussed one. When the squirrel cage induction motor is tendency to run at a very low speed compared to the single speed is known as a crawling. That is phenomena name is asked, that is known as a crawling. So these are my first part of this video. There is a 50 question, is there only 10 question we are discussed here. Okay.